In this example, we'll be graphing an equation of the form y equals a sine x. Graph y equals 2 sine x and compare to the graph y equals sine x. Well, compared to y equals sine x, y equals 2 sine x means that the y value will be twice as large. Now, since the normal range for sine x is -1 to 1, the range for 2 sine x will be -2 to 2. Now, let's take a look at a table in which I've selected the key x values, the key values of the angles that we would be most interested in, and let's fill in the table for sine x and then for 2 sine x. Now, for sine x, we have the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is -1. And the sine of 2 pi is 0. Let's do the same thing for for 2 sine x. Of course, this would still be 0 because 2 times 0 is 0. This, for pi over 2, it would now be 2. Would be back to 0 here. This would be twice that, so -2 for 3 pi over 2. And at 2 pi, we're back to 0. Now what we can do is reintroduce the axes. And let's first sketch y equals sine x. Remembering that we said we were 0, 1, 0, -1, and 0. And coming back this way would be -1, 0, +1, 0. So let's do that as a dashed line. And that's y equals sine x. Now let's draw the graph of y equals 2 sine x. Remember, the difference was that it would be twice the height in each direction. It'll still go through the same 0 points because twice 0 is, of course, 0. So our graph that we're interested in looks like this. So this would be y equals 2 sine x. Now let's see how we do this on a graphing calculator. Let's bring the calculator into the screen, and the first thing you want to do is make sure that you're in what's called the trig viewing window. So if you hit the zoom key, the middle top row, and then press the number 7 key, which says Z-trig, that will give us what's called the trig viewing window for our graphs. Now, we see a blank graph here, but if I now hit the window key right here, and we'll see that now the computer has automatically set it up to go from -2 pi, which of course is the -6.15, etc., to +2 pi for the x values. The scale, which looks like 1.57, that's really pi divided by 2. Then we have the y min and y max at -4 and 4, and the y scale is at 1. So the next thing we want to do is enter our equations. We do that in the equation editor, which we press the y equals key right here. We want to enter sine x, so we press the sine key, and then the key that has the x, t, theta, and n on it, it'll come up as x, and then I close the parentheses. I move down to the second y sub 2, the second row, and here I want to enter press the 2 key, then the sine key, then the x key, and close my parentheses. And now what I would do is press the graph key, and it'll first draw y sub 1, which is y equals sine x, and now it'll draw y sub 2, y equals 2 sine x. And you can see that this does agree with what we have. Y equals 2 sine x goes up to positive 2 and down to negative 2, compared to just the y equals sine x, which goes from negative 1 to positive 1 with respect to the range. In this example, we'll be graphing an equation of the form y equals sine bx. Graph y equals sine 2x and compare to the graph of y equals sine x. Well, I need to do some calculations in order to help us graph this. So here I have a sheet in which I've written y equals sine 2x. The first thing we'll notice is that b is equal to 2. And that means that the period for the sine 2x would be equal to 2 pi divided by b, which is 2, giving us a period of pi. That means one cycle of this graph, y equals sine 2x, will occur on the interval from 0 to pi. Okay. So that means, of course, the endpoints are 0 and pi. We now want to look at dividing that interval into 4 equal parts. So we know that 0 would be the beginning of it. Pi is the end of it. And the 3 key points that are between that, well, halfway between would be half of pi. 1/4 of the way between would be pi over 4, or 1/4 of pi, and 3/4 of the way would be 3 pi over 4. So those are the key points we wish to look at. Now let's look at the value of sine of 2x for each of these points. Now, the 0, of course, sine of 2 times 0, sine of 0, is 0. Now it would be sine of 2 times pi over 4. That's the sine of pi over 2 for 1. 2 times 1/2 pi would be pi. The sine of pi is 0. 3 pi over 4 times 2 would give us 3 pi over 2. The sine of 3 pi over 2 is negative 1. And now the sine of 2 times pi, so sine of 2 pi, is 0. So those are the key points that we'll put onto the graph in order to sketch this. So let's plot those points on a set of axes on which I've already drawn in a red dotted line y equals sine x. So starting with 0, 0, and then we move to pi over 4, which went up to 1. Pi over 2 was at 0. 3 pi over 4, negative 1, and pi at 0. So we can draw one cycle connecting those points with a smooth curve. But of course, the curve continues in both directions, and so we know that it will go up to here, down through there, back down to here, and we draw another full cycle. And now let's work out into the negative region. What we know is it'll go through 0 here, here, and here. Halfway, it'll be down to negative 1. Halfway between here up to positive 1, and halfway down to negative 1. So we'll continue the graph as such. And that's the graph of y equals sine 2x. In this example, we'll be graphing an equation of the form y equals cosine bx. Graph y equals cosine 2/3 x over 1 period. Well, first of all, let's determine what the period is. The period would be equal to 2 pi divided by b, and b is 2/3. So this would be equal to 2 pi times the reciprocal of 2/3, or 3/2, and therefore the period is 3 pi. So we would have one full cycle in the interval from 0 to 3 pi. Now, we want to divide that into 4 equal parts. So let's look at a table that I've created. in which our endpoints are 0 and 3 pi, halfway would be 3 pi divided by 2. 1/4 of the way would be 3 pi divided by 4. And 3/4 of the way, 3/4 of 3 pi would be 9 pi divided by 4. So now let's look at the values of first 2/3 x. 2/3 of 0 is 0. 2/3 of 3 pi over 4 would be equal to pi over 2. Then 2/3 of 3 pi over 2 would be equal to pi. Then 2/3 of 9 pi over 4 would be equal to 3 pi over 2. And finally, 2/3 of 3 pi would be 2 pi. Now let's take a look at evaluating cosine of 2/3 x, which would be cosine of 0. The cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. So our key points to graph are 0, 1, 3 pi over 4, 0, 3 pi over 2, -1, 9 pi over 4, 0, and 3 pi, 1. So let's bring back in a clean graph to work on. And what we then have, let me do this in the blue, is remembering we had 0, 1. So we'll put a point there. Then we had 3 pi over 4, 0. Then we had 3 pi over 2, -1. Then we had 9 pi over 4, 0. And finally 3 pi, 1. So our graph would be a smooth curve connecting these points. And that would be the graph of y equals cosine 2/3 x over just one period. In this example, we'll be graphing an equation of the form y equals a sine bx. Graph y equals -2 sine 3x over one period using the preceding guidelines. So let's look at what that means. We have the equation y equals -2 sine 3x. Now, step 1 is to find the period. Step 1. To find the period, since it's sine, we have 2 pi divided by b, and b is equal to 3. And so the period is 2 pi over 3. That means one complete cycle would happen in the interval from 0 to 2 pi over 3. Now what we need to do is to divide this into 4 equal parts. So we know that we begin at 0 and we're going to end at 2 pi over 3. Halfway would be pi divided by 3. 1/4 of the way, so 1/4 of 2 pi over 3 is pi over 6. 3/4 of the way, 3/4 of 2 pi over 3 is pi divided by 2. So that's step 2, is to find the 4, or to divide it into 4 equal parts, which gives us the 5 key points. Now, step 3 is to create a table. Now, I have a partially filled in table, which has the key points that we just calculated. Now what we're going to do is to find 3 times each of these. So 3 times 0, 0. 3 pi over 6 equals pi over 2. 3 pi over 3 is pi. 3 pi over 2 is 3 pi over 2. And 3 times 2 pi over 3 is 2 pi. Now we want to take the sine of each of these numbers in the second row. The sign of 0 is 0. Sign of pi over 2, 1. Sign of pi, 0. Sign of negative 3 pi over 2 is negative 1. And the sign of 2 pi is 0. Now let's find negative 2 times sine 3x. That means we're going to multiply each number here by negative 2. So that would be 0. 1 times negative 2 is negative 2. This would again be 0. Negative 2 times negative 1 is positive 2. And then this would be 0. Now step 4 is to plot each of those 5 points, which we'll do in a moment, because step 5 is then to actually draw the graph by joining those points that we just plotted. So let's bring in a graph and plot those points. So the points, remember, are 0, 0. Then it was pi over 6 and negative 2. Pi over 3 was 0. Pi over 2 went to positive 2. And 2 pi over 3 came back to 0. So now we join those points with a smooth curve. And that's the graph of y equals negative 2 sine 3x. In this example, we'll graph an equation of the form y equals a cosine bx, where b is a multiple of pi. Graph y equals negative 3 cosine pi x over 1 period. Let's go through the 5-step process. So let's start with y equals negative 3 cosine pi x. Step 1, remember, is to find the period. The period is 2 pi divided by b, and b in this case is pi. Therefore, the period is 2. And that means that one complete cycle occurs within the interval 0 to 2. Step 2 is to take that interval and to divide it into 4 equal parts. So the beginning is 0, the end is 2, halfway would be 1, 1/4 of the way would be a half, and 3/4 of the way is 3 halves. Step 3 is to make a table. I've already created the table with part of it filled in. Let's take a look. So we have the key points of 0, a half, 1, 3 halves, and 2. Let's take pi times x. Pi times 0 is 0. Pi times a half is pi over 2. Pi times 1 is pi. Pi times 3 halves is 3 pi over 2. And pi times 2 is 2 pi. Next, we want to take the cosine of pi x, which means the cosine of each of these. So the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Now we want negative 3 times the cosine of pi x, which means negative 3 times each of these values. So negative 3 times 1 is negative 3. Negative 3 times 0 is 0. Negative 3 times negative 1 is positive 3. Negative 3 times 0 is 0. And negative 3 times 1 is negative 3. Step 4 is to plot those points. And then we'll do that in a moment, with step 5 being to join those points with a smooth curve to find the actual graph. So let me bring back in the blank set of axes, and let's plot those specific key points that we just calculated in the table. We had 0, negative 3. Then 1/2, and the value there was 0. At 1, the value is 3. At 3 pi over 2, it's 0. And at 2, it is negative 3. And so our graph will look like this. And that's the graph of y equals -3 cosine pi x. Determine an equation of the form y equals a cosine bx or y equals a sine x, where b is greater than 0 for the given graph. When we look at this graph, we can think of this graph as that of cosine function reflected across the horizontal or x-axis. And if we do that, then we will come up with an equation y equals a cosine bx. Let's look at the amplitude first and notice that the height here is at 2. This trough here is occurring at -2, and therefore the amplitude is half of the distance from -2 to 2. So let's write down 1/2 of from 2 down to -2, which means that it's half of 4, and that means the amplitude is equal to 2. Next, let's look at the cycle. Notice that we have one complete cycle from 0 to 4 pi. And so that's on the interval from 0 to 4 pi. And so the period is actually equal to 4 pi. We'll take 4 pi and set that equal to 2 pi divided by b, and then solve this for b. So 4 pi b equals 2 pi, and that gives us b equals 1/2. We can now write the equation for this graph because we've determined b, which is 1/2, a, the amplitude here, and we said that it was the graph of the cosine reflected about the x-axis, which means we'll put the negative in front of the amplitude 2. So we have the equation y equals -2 cosine 1/2 x. In this example, we'll be interpreting a sine function model. The average temperature in degrees Fahrenheit at Mold Bay, Canada, can be approximated by the function defined by f of x equals 34 sine of pi over 6 times the quantity x minus 4.3, where x is the month and x equals 1 corresponds to January, x equals 2 to February, and so on. The first thing we're going to do is observe the graph over a 2-year interval, and to see the maximum and minimum points, graph f in the window 0, 25 by -45, 45. So let's bring in the calculator and enter the equation into the calculator. To do that, we want to hit the equation editor key, the y equals key. So we press y equals, and then we enter in 34 times sine. Now we need to enter pi divided by 6. We need to put that in its own set of parentheses. So I enter another parenthesis. I hit the second pi key to get pi divided by 6. Close the parenthesis. Now I need to enter a new parenthesis in which I will put x minus 4.3. Now I close that parenthesis, which is just for the x minus 4.3. I need to close the parenthesis for the sine function, so I enter a second parenthesis. Next, we'll adjust the viewing window. So we're going to press Window on the calculator key, and it will bring up the window which we had from the last example, which is the trig viewing window. We want to change it so that the x min is 0, the x max is 25, an x scale of +5. The y min we want to be -45, the y max +45, and we'll use a Y scale of 10. Now I will press the graph key on the calculator, and it will draw our graph for us. Now, let's see if we can identify what the amplitude is. I'm going to press the trace key on the calculator, and you'll see that if we look at the screen that the cursor is blinking at about x equals 12.5. Let me move that over just a little bit, and if I move back and forth, you can see that negative 33.99998, and that's occurring at approximately 13.29. What that means is that the amplitude is such that it's going down to almost negative 34, which means if I were to move all the way, let's go backwards this time. If I were to go all the way back up to the peak value, which is around here, and sort of search there, we'll see that again it's reaching 33.933857. So we can conclude that the amplitude is 34, which is what we would expect because the A value in front of the sign is 34. Also, what about the period of this? Well, if I trace back to the very beginning here, where there is the lowest point, which we know is the negative 33.998, notice that occurs at about 1.3. And remember that the last time when we had moved it over to the second valley, the second lowest point, or the second point that's the lowest point over there, that it was at about 13 point something. That tells us that the period of this is 13.2 or 3 minus the 1.3, so the period is 12. Now, 12, of course, corresponds to the months, and so you can see that this graph follows the changing seasons as it goes through its 1 year or 12-month cycle. Now let's take a look at part B. So I'm going to remove the calculator and bring in part B, which says, what is the average temperature during the month of May? Well, what we need to notice is that May is the 5th month, and so x is equal to 5. So we take our formula, our f of x, and we replace x with 5. So f of 5 is equal to 34 times the sine of pi divided by 6 times the 5, which is the x, parenthesis, the 5 minus the 4.3, and close the parentheses, and then close the square brackets. When we evaluate this, of course, we'll do it on the calculator, and we'll find that f of 5 is approximately equal to 12 degrees Fahrenheit. Now, we can verify that on the calculator. So let's bring the calculator back in. And we still have it on the trace function. So what I want to do is move the cursor to where we have, as close as we can, x equals 5. And that's too much. That's a little too little. So we'll go to x equals 5. And we'll see that the value is y equals 13. But remember that this particular graph is off just a little bit in terms of the phase shift for it. And so it is, remember we had to subtract 1 from this. So that would be coming out at about 12, which is the value that we just calculated using the actual formula for the function. Next, what we can do is part C. So let's bring in this. And it says, what would an approximation for the average yearly temperature be at Mold Bay? So if I take a look at the graph again, what we'll notice on this graph is that vertically speaking, which is the y value, we can see that it's more or less centered around the line y equals 0. So let's take a look at that. You can see that, let me move my cursor down to y equals 0, or as close as I can get. There we go. But you'll see that it's as much above y equals 0 as it is below. And so we can conclude from this graph that the average yearly temperature is right around 0 degrees Fahrenheit. So let's write that down as a result here, that it would be about 0 degrees Fahrenheit.